This problem asks us to prove a trig identity involving cosine, sine, tangent, and cotangent. We'd like to simplify it to sine plus cosine. As a rule of thumb, we'll work to simplify the side that has more trig functions. And we'd also like to convert that tangent and cotangent into sine and cosine so that it matches what we have on the right side of the equation. We'll start right away with making just that transition. The tangent that's in the denominator will turn into sine divided by cosine. We'll do the same in the second fraction. Where we have 1 minus cotangent of theta, we'll replace it with 1 minus cosine of theta over sine of theta. Now for just a little while, we'll focus entirely on the denominators of these two fractions. In the first, we'd like to get a common denominator down there. We want that denominator to be cosine. So we'll turn 1 into a cosine divided by cosine, leave the second fraction alone, and now they have a common denominator of cosine. In the second fraction, we'll do the same. The common denominator here will be sine, so we'll rewrite 1 as sine divided by sine, and subtract from it cosine divided by sine. These denominators look more appealing now because we have common denominators down there. So in this first denominator, we can combine those two fractions and get cosine minus sine divided by cosine. Then we'll do the same in the second fraction, where we have sine divided by sine minus cosine divided by sine. We can bring them together to make it sine minus cosine divided by sine. Now here, we're going to simplify each of these fractions by turning the denominator upside down using a reciprocal and multiplying it by the numerator. In the first fraction then, we take cosine times cosine to get cosine squared, and the denominator is cosine minus sine. Using the same principle in the second fraction, we multiply the sine times the sine to get sine squared. Our denominators now look almost the same, except for a little bit of signs in the denominator of the first. There's an algebra trick that'll let us multiply the numerator and denominator of this first fraction by -1. That basically lets us change the signs of each one of the trig functions in the denominator. So the denominators of these two fractions both look like sine of theta minus cosine theta. And because we have common denominators, we can now put these two large fractions together to get a single fraction. Sine squared of theta plus negative cosine squared of theta is the same thing as saying sine squared minus cosine squared of theta. And the denominator is sine minus cosine. We're almost there. The numerator is a difference of two squares, so it can be factored into sine theta minus cosine theta times sine of theta plus cosine theta. And since that denominator is still sine of theta minus cosine theta, we can see quickly that there are common factors between the numerator and denominator, which we're allowed to cancel out. And we're glad to see that all that remains is sine of theta plus cosine of theta, which therefore proves the trig identity.